Students, welcome back to CSC 143, Introduction to Data Structures. We are in Week 2, Chapter 9 of Building Java Programs, Inheritance and Interfaces. And in particular, we are going to be looking now at Section 9.3, Polymorphism. Polymorphism is probably the most confusing topic that we will deal with this chapter, so I'm going to spend a lot of time in code trying to explain it to you. Polymorphism is the ability of the same code to be used with objects of different types and producing different results, and specifically executing different code. Some of you may be more familiar with the word polyjuice from a certain very famous book and movie series. And in that case, polyjuice refers to a juice that can make an individual turn into a different individual, a different animal entirely. And it's not terribly unlike that. Polymorphism is the ability of one line of code to actually execute different lines of code depending on what kind of object it is. Now, before I go into the more details about these classes, I want to say that you've actually been using polymorphism all throughout CS 142 in the method toString. Okay, you call toString on all sorts of different objects. It's not technically polymorphism because you generally are always calling it, for example, you have an integer I, it'd be I.toString, or a string S, so you're going to be calling S.toString. So we can determine at compile time what the code that's going to be executing. So it's technically not polymorphism, but the point is that when you call toString, it executes vastly different code depending on what type of object it is, whether it's an integer or a string or something like that. That's the same type of thing that we're talking about here. Now let's talk about some specific examples. So here, if you imagine that there is a fruit class, and there's a subclass of apple. Okay, so subclass apple is a subclass that extends fruit. Okay, so here we create an apple class, that's the subclass, and we can assign it into the superclass object fruit. Okay, methods are called on Gala, the superclass. The version of the method local to the apple class or the subclass will be used. Okay, now you probably didn't understand any of that. When we get to the actual code, it'll make more sense. Let's take a look at the next slide. Okay, so what this is saying is that you cannot call methods on the subclass when you assign things into a superclass. I think we probably have a better example here. So this is referring to some slides I showed in chapter 9.1, where you have an animal class and then you have a cat subclass. So if I create a new cat here, which is a subclass of animal, I can assign it into an animal variable. And then imagine I do not have the code here where this is actually converting Tom into a cat, but instead I just have Tom, which is an animal, and I call .makesSound, and assuming that makesSound is only part of the cat class, then it's going to crash because there is no makesSound class on the animal class. It's a little bit confusing because I thought maybe the animal class might have makesSound, but let's assume that makesSound only is available in the cat class. So what she's done here is that she's converted Tom, the animal, into a cat. Okay, that by forcing it, it will now be able to call the subclass's method. Now, I would not be at all surprised if you are still confused at this point. So let's go into the code. First, I want to say that most students are confused about what polymorphic code is. When I ask students to write polymorphic code, I oftentimes get stuff that is not too different than this. And the problem with this kind of code is that every single line in this function here, I can tell you at compile time right now what line of code is going to be executed. Here, I've got a secretary. It's calling set hours. I know that in the secretary method, there's either going to be a set hours secretary here. There's either going to be a set hours method here, there isn't, or it's going to be in the superclass of secretary, which is employee. And here it is. This is the code that's going to be executed. Okay, I can tell you that for every single line in this method here, based on what type it is. But there is a way to do it so that we cannot tell what is going to be executed for any given line. So first, what we're going to do is we are going to create an array of employees. So let's create an array of employees. And there's this tricky terminology you can use here. You can actually create a new employee of John. Gotta close that. New employee of Richard. And a new secretary, Joe. Okay, so that's gotta give it a name. Let's call it staff, right? That's what you call a bunch of employees. You call it staff. And I've got to close this bracket there. Now I think it's probably just okay. I've got one too many, right? Instead of the close paren. Okay, so that created that. This is equivalent to creating employee staff equals new employee, and then you go staff 1 equals John, staff 2 equals Richard, staff 3 equals Joe. So this is just a syntax that you can shorten that up. Okay, so now I'm going to use the for employee E. Hopefully it's actually going to complain because let's call it emp because I've already used E in this. For new employee in staff, and in case you're not familiar with using this terminology from 142, this is equivalent to saying for employee emp equals employee open bracket 1 and then doing a for loop to over the number of items. So it's just a shorthand. So I'm going to grab for each of these, I'm going to say sysout, sysout, and then emp. This is just shorthand for emp.toString. Okay, make that more specific. Okay, so what is this going to do? So we've created an array of employees, and these are actually subclasses. Okay, so each item is potentially a different subclass of employee. Now we're gonna this is the polymorphic, well, let's put it right down here. For each element, this is polymorphic. And the reason why this line is polymorphic is because we don't know what code will be executed. Okay, is this going to be the secretary dot toString or employee dot toString? We don't know. At compile time, I can't tell. It could be either. So let's actually set a debugger and run. Okay, so when we get down to this code, we're just about to execute this. I'm going to step into by doing run step. I don't think I'm actually. Oh, I didn't debug it. Actually, didn't ran it. Okay, so we don't need that breakpoint anymore. Let's go on to the next breakpoint. Okay, here we are. Now we're going to do run step into. Okay, so where are we? Where is this toString? This is the employee toString. Why are we doing, I'm going to just step over this. Why are we doing employee toString? That's because that was employee John. Okay, I'm going to step over this and you can see it printed John. And now the second one is Richard. I'm just going to actually step over this one because it's, well, now let's step into it just to verify. So again, this is the employee, same line. It's going to print out Richard. Okay, now what is it going to do for this next one? We're going to step into it. We are no longer in employee land. We are now in secretary land. Okay, so it's now calling a different piece of code, which, although in this case it looks pretty similar, it is different code. We could not tell at runtime what that line was going to execute. And let's step back. So now it's going to print out Joe. Okay, and you notice that it's actually printing out different information, right? Because from, you may remember from my last video, that I deleted the hours and I just went directly to the employees, or the employee's name and then the secretary's words per minute. So let's go, so we're back to this code here. This is the only line of polymorphic code in this entire file, really. Okay. A lot of people think, oh, the polymorphic code is down in employee, or maybe it's down in secretary. Maybe it's the toString here. No, this is not polymorphic code. I can tell you exactly what code is going to be executed every single time we get here. Okay. And similarly, I can tell you exactly what code is going to be executed every time that it gets here. It's this code here that I can't tell what code is going to be executed, and it's going to vary depending on the different type. Now there is another line of polymorphic code down here, and that is down here. These two lines here, or 4 lines, these are technically polymorphic because we don't know what kind of object we're getting here. This could be a point object, it could be an employee object, it could be a secretary object. We don't know. And depending on what the object is, it's going to execute different code. I wouldn't really hold this up as polymorphic though, because you can tell at compile time what all the rest of these are going to do. These are not really polymorphic. It's really only this line, and it's just an if statement. So, but I want to try to illustrate to you what is the technical difference. Can you tell at compile time what the line is going to do? So this is kind of debatable as to whether it is. I mean, the overall function is polymorphic because you don't know what it's going to do, but this line here, you really don't know what code is going to be executed, and that's really the meaning of polymorphism. I want to show you a little bit more sophisticated example of polymorphism, because quite frankly, at this point, if you're still confused, you may be confused because these are really pointless examples. They're terrible examples. Why would you want to do this? And it doesn't seem very fancy because like all we're doing is printing out the toStrings. You know, anybody could do that. Let me see if I can make it a little bit more challenging. So I'm going to add into this array, I'm going to add in, I think we've got E1 and E2, S1 and S2. Right? Okay, let's just double check that this is going to work. I'm going to run that. No, that didn't work. What was the error? Oh, I guess I didn't have an E1. Oh, I had E. Okay, sorry, E. Run that. Okay, so what this did is it printed out E1, E2, well, E, E2, S1, S2. Okay, so great. We're doing that now. Actually, there's more than that, right? Yeah. Here, let me give it some new lines here. Okay. And there we go. So here's the new stuff. All right. So this is the list. 1, 2, 3, 4, 5, 6, 7 people in this list here. And let's try doing this out for each of these 7. Actually, let's just do it right at the end of the line. Let's try to print out something that's in the employee class, the hours. Okay, we're going to print out that, and we're just going to say worked a total of, and then we can do employee dot get hours. Well, yeah, it's actually supposed to be, let's say works, right? It's the number of hours that they work a week. Works this many hours per week. And instead of toString, let's make it a little bit. Let's make it get name. Okay, the name. Let's try that. Okay, so John. Okay, let's put a space there. Works 40 hours per week. Okay, so the default ones we're working 40 hours per week. I do have I forgot another space over here, but there were a couple guys that I set to 50 hours a week up here. Here's where they set 50 hours a week. Okay, so that's gonna work fine. And now let me try, instead of hours, let's try the get WPM. And if you remember from that slide I was showing, there's a problem. The problem is that get WPM is undefined for type employee, right? So one possibility is, well, we can just force this to be a secretary. I'm going to force employee to be a secretary to call it. Now, the compile time error goes away. Okay, it's no longer compile time error. But what happens when we run it? You run it, boom, it crashes. And that's because not everybody in this list is a secretary. When we try to do it for John, it's going to crash because you can't force it to get WPM. Okay, so here's where we can use instance of. Let's create 2 copies of this line. And let's say if emp instance of secretary, then we're going to use this force. Otherwise, we're going to use this one. And well, we really need to say types that words per minute. And we still crashed because we're trying to convert cannot be cast. Oh yeah, I forgot it. I got to remove this. Right. This has to go back to emp and get hours. Okay. That should. I just got to get rid of that extra bracket, and now it goes away. Okay, so we have the employees showing hours per week, and we have the secretary showing words per minute. Okay. Now, here's a question. Is this code that I wrote here polymorphic? Well, if this code, this particular line of here, so I would say that overall it's polymorphic, but we're specifically checking the types, right? So it's kind of a weak polymorphism because we're manually checking the types. Ideally, polymorphic code shouldn't be checking types. It should just be doing the right thing depending on whatever method there is. I know it's a little bit confusing on that point, but I wanted to show that you can only call, when you've got an array of these things, you can only call things in the super class that you've defined that array for, and not things in the subclass, unless you're actually checking to make sure that you've got the right object, that it's the proper subclass. I want to give you one last example of polymorphism. I want you to stop looking at the code and actually just look at this application, at this Eclipse. All applications in Windows and on the Mac and on Android, they're all windowed applications, and they use object-oriented programming. So in this case, Windows, there's an actual object called a window, okay, that is represent every single window that you see in here. Here's one, here's one, here's one, here's one. These are all windows, okay? And every window has an X and a Y to start. I'm not sure what, I can't remember what the origin is, and it's got a width and a height, okay? And when I go in here and I grab this divider and I slide this over, okay, what's happening, and the reason why these windows repainted so nicely, is because each window has to support a method called draw, okay? And when I move this border over, the windows figures out what the new width and height, what the new XY is. It updates those for the window, and then this window has to redraw itself by calling draw. So somewhere in Windows, there's this loop that continually, whenever anything gets updated, goes through all the windows on the display and calls draw on them. And the windows are responsible for drawing their contents. So when I drag this up, okay, it's gonna hide those lines of code. When I drag it down, those lines reappear. Windows doesn't know anything about the text that's in here, but Eclipse implements this code window here that does know what's in here. And when it says, oh, you know what, my X and my width and height, my height got really short, it knows that it no longer wants to display that, but when I do this, it gets a call to draw and it says, oh, hey, look, my height is really tall now and I need to draw these other lines. Okay, so that's an example of polymorphism. Every single application that you use on Windows, on the Mac, on Android, they all use object-oriented programming and specifically polymorphism in order to be able to draw all of these different things. Other examples are when I click on a menu here, okay, the people who wrote Eclipse didn't need to know how to draw a menu. It's actually just a list of these elements in an array somewhere that they've passed into Windows. But Windows knows how to draw a menu. And so the draw method is being called on all these methods, okay? And this is, again, reuse of code and an example of how polymorphism makes all of this work. Really, without object-oriented programming, Windows couldn't exist, the Mac couldn't exist, the Android couldn't exist. We need object-oriented programming to be able to do this. So polymorphism is a complicated subject. The main thing you should take away is that polymorphism is the ability of a single line of code, like this line right here, to call different code depending on what the object is. Okay, normally we've just been dealing with a single type of object. Here, this employee could be an employee, it could be a secretary, it could be some other subclass of employee. We don't know at compile time what code is going to be executed. That is polymorphism, and that is how we can reuse one piece of code, have it call all sorts of different code, and create all sorts of different behaviors. The last book section of 9.3 is interpreting inheritance code, and it uses a lot of very fancy diagrams and tables to figure out when you call polymorphic code like this, what exactly is going to get called. And you saw how that works when I stepped through this code, and we could see, well, maybe not this line, but before when I was stepping through to see what line of code was going to get called in which class. That is a more formal way of doing what I showed. And to be honest, if you develop your classes clearly enough, you shouldn't ever have to do that. I personally don't like the kinds of problems that the book has where they try to trick you, because that just is a sign of poorly written code. But anyways, I'm not going to go into that, and let's talk about the examples at the back of the book, though, for chapter 9.4 or 3. So chapter 9.3, it should be problems 10 through 17, but unfortunately this is the only problem that they have in practice it. But this is a good problem because the main thing to remember here is that you can take a subclass and assign it to a superclass, but you cannot do the reverse, okay? That's the main thing you need to know here. But there are some interesting problems in here. I would encourage you to take a look at the other ones from problem 10 through problem 17.